Hello, sir.
Hello,
Good
guys.
evening,
How are
Hello,
you?
sir. How are you? Hello, sir.
Hey, hey. Good, thank
I
you. It's
was,
good to see you guys after a while. Sorry I couldn't
I
make it
was,
last week. Hope everyone's had a good couple of weeks.
yes, sir. It was a nice week.
Yeah. Got it. Okay. Very cool. Very cool. Alrighty. Let me get this started. And we'll go from there. So let me know when you guys can see my screen. I hope that's started for you.
I can see your Zoom, sir.
Perfect. Okay, cool.
I can see. Light.
Awesome. Thank you. All right. So, today's class we're gonna cover, as you said, light. Just a reminder, guys, as always, when I'm sharing my screen, I can't really see all of the cameras. So if you want to say something, just pop your hand up for me. I'll call your name out, and then you can share whatever you need to. So, just before we go on to the topic itself, just to cover homework, guys, thank you for everybody that did send it through. Most of you sent through the completed ones, but I don't believe, and correct me if I'm wrong, but I don't believe I received it from Prinsika, Satvika, and Rahul. The three of you guys, am I right? Did I not get that one?
Yes, sir.
Yeah? Okay. Can we just make sure, guys, going forward that please before the class, at least 1 hour before at the latest, please send it across to me so I can. It's for you guys as well, right? It's a way to learn and it's a way to compare because we can then go through the answers the next day. So please make sure you get it done for next week, okay?
Sir, can you wait over here? I'm just going to see the correction if I have any wrong.
Yep. Absolutely. So we'll run through it together. So the first point is puddles of water dry up in the sun. They dry faster when the day is hot, right? So this is referring to the process of evaporation. So when you've got a puddle of water, that water evaporates, becomes a gas due to the heat from the sun. And that speed of evaporation increases when the level of heat is higher, right? So when it's hot, it dries faster. Now, washing dries faster in the sun than in the shade. So like your clothes, right? They would dry faster when they're exposed to the sun rather than being covered in the shade because there's no heat in the shade or very little heat. Your skin dries faster when the sun warms it. Again, similar process, similar concept. If I put my bucket of water in the sun, it dries up, right? Because of evaporation. And then you can change liquid water into gas by heating it. So relates to the first point where when the water dries up due to the sun, it's changing from liquid to a gas. Dinishan, I see your hand up. Do you have some questions?
Sure. Number one, I correct the pool of water dry, but I wrong. I put the hot up in the hot, sir.
Yep. Okay. I get what you're saying. So you've got the right idea and the concept is right. But when you're writing it in English, the better word to... Yeah, sorry,
yes,
go ahead.
sir. The better word is change.
Yeah. So you understand why it's better to put sun?
Yes, sir.
Okay, perfect.
Because
Awesome.
water dry up in the sun.
Yes.
It will dry, sir.
Yeah, perfect. Okay.
Sashwin
As long as you
got
understand it.
everything
Thank
right,
you,
sir.
Dinishan. Give me 1 sec, Sashwin. Sorry. Sarwin, did you have something?
Yes, I have only one. The second one, washing dries faster in the sun than in the shade. I have to put dry, sir.
Okay. So you put dry in after washing?
Yes, sir.
Okay. And do you understand why it's dries versus dry? Or do you want me to explain that one?
No. Can you explain me that, sir?
Yep, absolutely. So the word dry is not a process, right? So you don't say washing dry faster because nothing's happening to the washing. But if you say washing dries, that's the action. The dry is a state, whereas dries is an action. So the washing dries, it's changing. Whereas if you say dry, it doesn't make sense with wash. So washing dry, it doesn't go together. So dries is the action of it happening.
Okay, sir.
Does that make sense? You sure?
Yes, sir.
Okay, cool. Ritishan, yes, I see your hand.
Same as Arvin, I also made the mistake for the second one, but the mistake is different. I made a mistake of the shade. Instead of shade, I put hot.
Okay. Sorry. Again, did you have any questions as to why it's shade and not hot?
Yes, I have some questions about it.
Yeah, go for it. So what when you say washing dries faster in the sun than in the hot, the sun and the hot like kind of refer to the same thing, right? So you can't say it's happening faster in one side than the other if they're both very similar. How come you went with hot? What was your thought process there?
I thought that the hot time was just a little bit hot, but the sun was like there was also light hitting on the bucket.
Okay.
I was thinking.
I see. Yep. The only thing I would say there is there was no real context as to the intensity of the heat, right? So the sun and hot, they don't refer to the same type of things. So the sun is referring to, I guess, an object, whereas hot is referring to the climate. So when you say washing dries faster in the sun than in the hot, because when you're saying sun versus hot, it's if you were to put hot in the sentence, that implies that you're saying washing dries faster on the sun rather than in the hot. But we can't put washing on the sun. Does that make sense?
No, sir.
No. Okay. Let me go again. So.
Oh, yeah, sorry, sir. I thought that you were asking about the on the sun, that thing. But the whole topic I understand. Not not
cool.
on the sun. Cool. On the sun.
Okay, cool. Sounds good. Sashwin, I see your hand.
As Ritishan and Sharwin said,
just hold your mic up closer for me, Sashwin. I can't hear.
As Ritishan and Sharwin said, I got the only wrong one was the second. The wrong answer was washing skin faster in the sun than in the shade. I put the skin on the second one. That's why it's mine wrong. Now I just read the sentence and I the meaning was not correct. So I just wanted to tell you about it.
Perfect. Thank you. So you're right. So if, for example, the word dries was already there and then there was a blank between washing and dries, you could have put skin, because you can say washing the skin, washing of the skin dries faster because the skin will dry faster. But because there's no context there, you can't say washing skin faster because there's no action word there for it. So perfect. Thank you. Ritishan, sorry, I still see your hand up. Anything else?
No, sir.
Okay,
I forgot to know it.
That's okay. No worries. All right, perfect. So I'll go on to the actual content for this week. So with light, a result of the light is shadows, right? Now, there is somewhat of a pattern when you look at shadow formation. For shadows to occur and take place, a source of light, right, as you can imagine, is needed. And that source of light is projected onto an object that does not allow light to pass through it completely. So what I mean by that is, let's say you're looking at this, you have the sun. The sun creates light, but if you have just a pane of glass, that sunlight will pierce straight through, right? And no shadow is created from that glass itself because the object allows the full light through. For a shadow to be created, the object itself needs to limit or cut the light that's getting passed through. Now, when that happens is where a shadow forms on the opposite side of the light source. So as you can see, if the light is coming from the left, on the right-hand side is where the shadow will form. Now, the size of shadows are impacted by the angle of the light source. The distance from where the light source is coming doesn't impact the size of the shadow. It's only the angle which changes and varies the size of the shadow. The lower the light source, the longer the shadow. The higher the light source, the shorter the shadow. Before I go on, I just want to put it out to the class. Does everybody understand the two things I just went through with shadows? So talking about how they're formed and then also how their size is impacted. Dinishan, I see your hand up.
Sir.
Yes.
Sir, this is the picture, right, sir? This one.
Sorry, can you tell me again? Sorry.
This picture, angles picture, right, sir? We need to. This is mentioned what, sir? I confused
Okay. Which one? The top half or the bottom half?
Bottom half one, sir.
Okay, bottom half I haven't got to yet, so I'll do that in the next part. So that's talking about how the direction of the shadow changes over time. I'll get to that in 1 second. Sarin? Yes, I see your hand up.
Yes, I didn't understand the first one.
Sorry, you didn't understand which part?
The first page, sir.
Yes, sure. Okay, so let's go back. So, for shadows to form, right, you need two things. One is a source of light, and two is an object that limits or does not allow the light to pass through. So what I was saying was, if this ball was, a piece of glass, the light will strike straight through and there won't be a shadow because the glass allows the light to pass through. Because this one is a ball, the light is coming here, getting blocked by the ball, which then creates the shadow on the bottom. Does that make sense? Any questions there?
Yes, sir. No, sir, I understand it now.
Yep. Any questions with that one? No?
Sir?
Sure.
Sir?
Yes, Sashwin?
If we put the glass in the middle of it, if the light comes, like you were saying, it's transparent, right, sir?
Mm-hmm. Yeah.
That's what you were saying, right?
Absolutely. Exactly right. Yes.
Right.
Yes. So because it's transparent, the light will pass straight through. So even if we put like you were saying, Sashwin, if we put a pane of glass in between, the light bulb and the ball, it will still have the same effect because the light will pass straight through the glass and eventually hit the ball, which then creates the shadow. Cool. Anybody else, any questions before I move on regarding the creation of the size of the shadow or anything like that? No. Okay, perfect. Now, if you observe an object's shadow from morning to evening, right, this would be the results. And the reason the results change is the sun, right, it moves over the day. So if you look at the sun from morning to evening, it starts on one side, goes to the other. So what happens in that case is there will be a long shadow early in the day. So you can see, say 9:30 a.m., the light comes in, hits the object, and there will be a long shadow. Because we were saying the lower the light source, the longer the shadow. As the day goes by, we hit 10:30, 11:30, 12:30, you can see the length of the shadow will get shorter and shorter. Because you see this one, the shadow will go to about here. Then this one, it will stop about here. And then 12:30 will be right on top. So you will see a very small shadow just around the object. As we pass noon and the sun starts to go the other way, the light source starts going lower and lower again. So what you'll see is the shadow becoming slowly longer, 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 until we, of course, hit the evening or nighttime where the sunlight disappears. Any questions with that explanation there? Dinishan, you were asking about the diagram. Does that make sense now that we went through that one?
Sure.
Do you have any questions? Hold on, Sashwin. I see Dinishan's hand. Yeah?
What is, sir? I cannot understand, sir. If you observe an object shadow from morning to evening.
Yep. Okay. So what that's saying is, if you were to put, for example, if you take a basketball and put it on the street, and then you just sit there all day from 9:30 in the morning, and you measure the shadow. Then at 10:30, you measure the shadow. And you keep doing that throughout the day until 3:30. When you look at all your results that you've written down for the measurements of the size of the shadow, because the rule is the lower the light source, the longer the shadow. At 9:30, when the sunlight is closer to the horizon, right? The length of the shadow created by the ball is going to be longest. Then as the sun rises to the middle, around 12:30 p.m., when the sun is directly above the ball, that's when you will see the smallest shadow, because the higher the light source, the shorter the shadow. Then as afternoon, as the sun comes back around to the other side, you will see the shadow become even longer, because the light source is becoming lower and lower, right? It's going from the highest point back down lower, because the sun has risen, it's gone to 12 o'clock at noon, and now it's setting again, back down to the horizon.
Okay, sir, I understand.
Okay, perfect. Sashwin?
Yes, sir. In the first picture, the shadow is bigger, right, sir? So in the first picture, is it morning?
Yes, correct. Exactly right.
So the second picture is it's 12:30 p.m., right, sir? And the third one is the shadow is getting lower, right, sir? So it is getting night. It is getting almost night, right, sir?
Correct. Exactly right. Exactly right. Exactly right. So, as you said, it's, the rising, the 12 p.m. noon right at the top, and then the setting after that. The only thing I would flag is, I'll put it out to the class. Does anybody know what side does the sun rise from and what side does it set? If you're thinking about a compass. Just put your hand up for me if you know the question on Zoom, and then I'll say your name. Sarin, yes? Can you give me which side it rises from? And then Dinishan, if you can tell me which side it sets from. Sarin, you there?
Yes, sir.
Yeah.
I think, I don't know clearly, but I think it's the east, sir.
Perfect. Absolutely. Rises in the east, correct. And Dinishan, what side would it then set in?
West.
Perfect. Exactly right. Thank you, guys. So it would go east to west. All right. Now, let's go here. Now, measuring light intensity. Sarwin, sorry, I see your hand up. Is that from before or you have another? Cool. Now, there is a way, or there are a few ways for us to measure the intensity of light, the power of light. And that can be done through the use of something called light meters. Now, light meters can be inside cameras, or they can be separate devices as well. So you can see on the right-hand side here, in a camera, like a digital camera, when you're taking a photo, there will be a small icon which refers to light intensity. Then you also have these individual devices which are purpose-built purely to measure the intensity of light. These meters, whether they're in the camera or they're the independent devices, they all have a cell which is inside. This cell reacts to the light and produces an electric current. The current then produces the movement of the pointer on the dial or number on the screen. So it's the current, right, which then produces the result that we get displayed on, the devices there. The greater the light, the higher the intensity, as you can imagine. And yeah, that's pretty much it. So it's just explaining that there is a way for us to measure the intensity of light that can be done through certain devices. Sashwin, question?
No question, sir. I was telling that in our phone also have weather climate, sir. It is called weather climate. If you want to see is it going to rain or sunny, you might see in your phone. It's an app called weather climate. Even me, I see is it going to rain or sunny. So I think it might also a weather climate scene.
Yeah,
device.
Sure, definitely. Ritishan?
I want to know how did the device that a man is holding on his hand works. Like the device you what's that? You said introduced to
the
us.
Light meter?
Yeah, that thing. The light meter. Yeah. How does it work?
So on a very high level, it basically has a cell which then reacts to light to produce an electric current. I won't go into too much detail in this class, only because it's not a major part of the curriculum that you need to know. But what we can do, and if you don't mind, I'll get you as a task for next week, which might be cool just to hear about them. If you can watch a video or two before next week's class about light meters, and if you can give us a quick 30-second wrap next week on how they work. Would that be good, Ritishan?
Okay, sir.
Sir, I might do it just like same, sir. I might search in the Google or in YouTube, and I will learn it and tell you about in 30 seconds.
Perfect. I'd love to hear about it. I just don't want to spend too much time on it in this class, just because we have a few things to cover. Sir. But if you, please have a watch. Sorry. There's heaps of videos on YouTube. I had a look at them while I was creating the slides. There's heaps of them on YouTube. So just search up light meter. How does it work on YouTube? And then we'll go through it next class, right at the beginning. Alrighty. So opaque and transparent materials. So remember we were talking at the beginning how certain objects can let light to pass through, and other ones will either have a minimizing effect or completely stop the light from passing through as well. Now, if the light is able to pass completely through, I think Sashwin was the one talking about it. He mentioned these are transparent. right? So this means that we can clearly see objects on the other side of the object because it allows the light to pass completely through. Just quickly, which one of these three is the transparent object? Someone pop your hand up for me.
Sashwin tell, sir. May Sashwin.
Give me 1 sec. Sorry, Sashwin. Ritishan had his hand up first. Tell me, Ritishan.
Is it the glass and the ice?
It is the glass. The ice is a bit of a tricky one because I'm gonna pop it in the next one, but definitely the glass. Ice can be.
Sir, it's the glass, sir.
Hold on, sorry.
It's the glass.
Hold on. Ritishan, sorry, you're right. So it's the glass. Now, ice can also be transparent depending on how the ice is made. So you guys might have seen videos where people make very, very clear ice, right? And in that case, yes, it is transparent. But in other scenarios, the ice can be translucent. So they only allow parts or partial light to pass through, changing the way we see objects on the other side because the light becomes distorted, which then changes the image, right? So if the ice is not fully clear, but you have a big slab of ice in front of you, trying to see something on the other side, what you'll notice is that, yeah, the object on the other side is a little bit distorted because the ice is not fully clear, which then changes the way the light is passed through. The last point is that who was that one? Sarwin, yes?
Sir, I looked at the YouTube that the eyes are like it is above the water and the cold condition. So that's why it is like that. So not clear, it's like that.
Yeah. There's different kinds of ice, as you said. So you can, depending on the climate and the temperature, create fully clear ice. But usually, right, if you go into the freezer, pull out your ice tray and have a look at the ice, it's not going to be clear. It's going to have like a cloudy interior, which if you have it on a large scale and push light through, you won't see the object on the other side very clearly. It will be distorted. Now, on the other end of the spectrum, we have materials that don't allow light to pass through at all, and that's referred to as opaque. Dinishan, I see your hand up. You have a question?
Sir, can I... the rock is what is, sir? Rock
Good question.
Transparent.
Good question. So what do you think, Dinishan? Out of the three items, transparent, translucent, opaque, which one do you think the rock is?
Opaque.
Say again? Opaque. Yes, opaque. Exactly right. Because with the rock, it's not going to allow any light to pass through. Now, we're going to move into, and this part has a little bit of content, guys. So I'm going to start talking through it. Put your hand up on Zoom for me if you need me to stop and explain any of the sections because there's a fair bit to it. We're going to talk about light and the eyes. Dinishan, yes, I see your hand.
Sir, just now, what is the transparent glass, right, sir?
Can you say again for me, sorry?
The item of these three pictures is transparent glass, right, sir?
Correct, yes.
Translucent is ice, right, sir? Ice cube.
Translucent is ice, yes.
Thank you, sir. That's I want.
No problem. Perfect. Ritishan, yes?
You said that ice can be like translucent, right? But sometimes if you take some water, first you boil it, then you change it into ice, it will be like, how to say, it will be kind of clear, not like cloudy.
100% right. So because you're doing that change in temperature first, you're exactly right. Those are the videos you would have seen, right? How people make the really, really clear ice. It's using that process. So boiling the water, then freezing it, and you'll see they might even put it in very special containers. Those ones have the clear ice. Correct. And that's where you would have a change from it being translucent because the light goes from being partially passed through to then becoming transparent because the light can now fully go through.
And I want to ask, how is it even possible to be like that? How does it work?
Possible?
How does it work? I mean, how does it work? Like water and boiled water is like kind of the same, but the temperature is different. But I want to ask, how is it being like very transparent?
So I would say it comes down to the composition of the water itself. I'll be honest and say I don't know the exact science behind it. I'm happy to look it up. And then we can go through it again in next class. So this one I'm not 100% sure of, but I would say it comes down to the composition of the water itself. So because you're heating it to change the way it's formed and then you're freezing it is what creates that clear ice. But it's a good point. We'll have a look at it and we'll chat about it next class for sure.
So I have one thing about it. When the water is kind of like dirty, I mean there's some germs inside the water. Like if you take some water, you cool it, you slightly cool it, like how to say, like 1 hour. Then you take it out without even shaking it. Then if you even touch it or do something, there will be like transmission ice. But and because of heating it, oh sorry sir, I made a mistake.
I know you meant that you took the dirty water and then you boil the water. Is that what you were trying to say?
Wait a second, sir. Like if it's dirty water, I mean not that much dirty, like this, but there's good germs or anything, any moving particles inside it, and while freezing, if it moves, the particle moves, it will create unclear ice. If it doesn't move, it can't create that much unclear ice. But if now, how to say, if you boil it, all the living things inside the water will die. Then if you freeze it, nothing can be able to move. Then it will be clear ice.
Yep. Makes sense, definitely. Sashwin, yes?
Sorry for taking too long.
That's okay, mate. That's okay. You got there in the end. It's important. Yes, Sashwin? Sorry, mate, can't hear. Sashwin, Mike.
You know, sir, the igloo, right, sir?
Yeah.
In igloo,
actually,
yeah.
Sorry, go ahead.
In igloo, there's a like a big ice, right? So they made the igloo with some ice, right? So like a big ice, right?
Yeah.
If you put the ice on a table on a floor, if you use your eyes and to see it, you might see things clear, a little bit clear, and not that much clear, a little bit clear. If you in future you put like small ice, right, sir? If you take it and see that thing, you can't see it clearly. It's more clear than the big igloo ice.
Yeah, so that would also come down to the climate and the environment that it's in. So what we'll do is, like we were saying for Ritishan as well, we'll go back. So there's two things to have some a look at in terms of videos. So the first one, we were talking about how light meters work. And then the second one is in terms of how clear ice is created. So we can have a watch over the next week on those two processes and have a chat about it before the next class. Cool?
Yes,
now,
sir.
Perfect. Now, light and the eyes. Now, I'm just weary that we're running short of time. What I might do... Okay, I'm going to go through these ones really quickly without stopping for any questions. And then what we'll do is, at the end of the class, if we have time, I'll run through it, okay? And then we can cover any questions next week as well. So, light and the eyes. Now, the front of the eye is covered with a transparent substance called the cornea, which bulges slightly. So you can see here, this bulge, that's the cornea, and it's a clear, transparent item. Now, the cornea is there to protect more delicate parts of the eye, which sit behind it in this section here. Now, as light enters the eye, it initially hits the cornea, passes through, and goes into the pupil. Now, the pupil you can see in this diagram up here. So the cornea is a film in front of it, right, bulging out. The light hits it, then goes through the pupil. Now, depending on the intensity of the light, the size of the pupil changes and adapts. Now, the iris, which is the external circular section of the eye, is the iris is the external circular section of the eye. The size of the pupil is changed through the contraction and relaxation of the iris, right? So there's tiny muscles in there, which as they contract and relax, the size of the pupil changes. Now, when the intensity of the light is high, the iris relaxes, which then reduces the size of the pupil. When the level of light intensity is low, the iris then contracts, which opens the pupil to its maximum size, right? Allowing us to see more and see in the dark. Just before I move on, just quickly making sure that everybody understands the 3-4 things that we just mentioned. If you have any quick questions, let me know. Sarwin, yes?
Yes, I can understand how the iris works.
You can or you can't?
I cannot, sir. How the iris works.
Okay, cool. So the iris, okay, which is the black part there, right? So that one is, the iris, which is the outside part around the black, which is the pupil, those have muscles in them, right, which contract and relax. So when the iris relaxes, right, the pupil becomes smaller, and when the iris contracts, the pupil becomes larger because the muscles are pulling away, right, in the iris, which then makes the pupil become larger. And when the iris relaxes and the muscles let go, the iris becomes smaller. The pupil becomes smaller. Sorry. I've been saying it wrong. Is that all right? Does that make sense?
No,
it doesn't.
I can't understand what I'm saying, sir. But is the iris that we call iris that are blue?
The blue part, correct.
Oh,
yes.
Okay, sir.
So the blue part doesn't like we don't see using the blue part, we see using the black part. The blue part is there to change the size of the black part depending on the strength of the light around us. Yeah?
Okay, sir. I understand now. It's clear.
Okay. Ritishan, I see your hand.
Oh, sorry, sir. I forgot to lower it.
No worries. Oh, good. Sashwin, I see your hand.
Yes, sir. As Sarwin was asking, that as you always telling that the blue things just when we are in a room, if the lights
just bring your mic up. Sorry, Sashwin, your mic closer.
When we are in a dark place, our eyes just get bigger because the thing that you say, the blue things get just bigger. So that's why the pupils see well. In the dark.
So,
that are
in reverse. In reverse, sort of in reverse there. So in the dark, right, the
Yes,
iris
sir.
contracts. So the muscles pull closer together, which makes the pupil bigger, allowing us to see, right? So the iris doesn't become bigger, the pupil becomes bigger. Then when there's enough light and there's a lot of light, the iris relaxes, which then makes the pupil smaller. Dinishan, I see your hand.
That's what I was telling, sir.
Perfect. Dinishan?
I understand this is 16 times bigger than a minimized size.
Yes. Okay. So what that's saying is when there's a lot of amount of light, the pupil will be very small. And then when there's a low amount of light and we need to see a little bit better and see in the dark, the pupil itself can become up to 16 times bigger than its smaller size. So you know how we were saying in the dark, the pupil becomes larger because the iris muscles contract, right? As that pupil becomes larger, it can be up to 16 times. So up to its smaller size, it can be 16 times bigger.
Now I understand it.
No worries. Now, the size of our pupils is not something that we actively manage, right, as human beings. It's an automatic reaction to the intensity of light. Now, all light is sent out using rays or beams, right? So what I'll do, we're a bit short on time, so I'll skip through this, but essentially it's just saying that we don't actively manage, right? You and I don't think about going, oh, let me make my pupil bigger or let me make it smaller. It's an automatic reaction our body has to the intensity of light around us.
Yes, sir. I understand this one.
Cool. Now, reflection and vision. Now, luminous objects produce light. Actually, what I'll do, we're running very short on time, so I'll skip this part. We'll go through it next week because there's a fair bit. So I'll make sure I put this in next week's lesson. Okay. A quick one. So this week's homework is going to be a little bit of a different one, not a fill in the blank. Okay. So what we're going to do is group the items here into whether they are sources of light or non-sources of light. And then under each one, whether they are artificial or natural sources. Okay? Any questions with that task there?
Sure.
Put your hand up for me, whoever's talking, please. Yes, Ashwin?
There's two things to underline, right, sir? One is a source and one sources. So if we put the sources and one sources the same like underline, so what how do we can see it that this is the source and another one is the one known source? How do we find it? Do we have the circle one of them? Do we have the circle or other one we have to underline?
That's okay. Probably the easiest thing to do is you can either do it on the diagram itself if you want to print it and do it, or you can just write a table in your book and just do in the heading sources and non-sources. And then under each heading, you can write the letter that corresponds to each image. So you can say sources, for example, is H, J, K. And then next to it, you can say, okay, H is natural, J is natural, K is artificial. Yeah?
Yes, sir. Yes, that is what was thinking. I was just making sure that I ask you.
Yeah, not a problem. Anytime. Questions are good. Dinishan, yes?
There is a double I, sir.
This one is I, this one is J, this one is L.
Oh.
Yes.
Thank you,
cool.
sir.
No worries. Okay. Now, Just a reminder, right? As we've said, there will be a test coming down the track. So just make sure you review any content through either the YouTube recording and also the slide deck that we upload. Okay. Write notes where you can. Highlight any questions that you have throughout the week on our WhatsApp so that I can answer any of those in the following class before we go on to the next lot of content. Okay. So just a reminder, go through the content. Any notes, write it down, and any questions, please put it in our WhatsApp. You can put it in the WhatsApp at any time in our group chat, okay? You don't have to wait for the class time. Pop them in, and then we can have a chat about it all the next week. As you guys know, we're doing content from both classes now in the Kahoot, so we're across all of the info. And one new thing I want to start with you guys, right, from next week is just a small presentation. So nothing too crazy. And we'll choose 2 people each week to do the presentations. So for next week, Loka and Rahul, you're both on the call, yes? I can see you guys. So I want you guys to do just for a quick one next week, just 3 minutes, nothing crazy. Okay, a presentation where you can talk about anything you want. It doesn't have to be science related. It can be about yourself. It can be about your family. It can be about what you like to do, your hobbies, anything at all. You choose it. But I just want you to do a presentation, maximum 3 minutes, so not a long one. So you need to outline the title, introduce yourself, and then follow the what, why, how method. So 3 things, okay? So I want you to talk about what, why, and how. So in the example, of stars, if you were talking about what are stars, you define what they are. The why section would be talking about why stars are important in the world, providing light, heat, energy, for example. And then how. So describing the life cycle of the star. So that's just an example. Like I said, it doesn't have to be science related. That was just to give you an idea of what the structure is like and what you need to have. So title of the presentation, introduce yourself, then follow the what, why, how, and maximum 3 minutes.
Sir?
Sarin, yes?
It sounds like
Sir, is it like that? Yeah, we can introduce anything like
anything you want. Just choose one topic. Just choose one topic, and then you can talk about it for 3 minutes.
Like we can do about stars, how stars work, and why is it? Okay.
That's an example. Absolutely. Loka, I see your hand up.
What, why, how? we make the question or?
No. So what, why, how is more just a structure for you to use in terms of your presentation. So to cover the content, right? So it's just to help you structure what you're presenting.
Okay, sir. Thank you.
Is that okay? Yeah. Rahul, since you're presenting, mate, any questions for next week on this one, or it all makes sense? Rahul, you there?
Yes, sir.
Just checking if you have any questions, mate, because you're doing next week's presentation. So does it all make sense for you?
Yes, sir.
On what's required? Yeah? Okay, perfect. If you have any questions, guys, throughout the week, please pop them in the WhatsApp, like I said, especially Rahul and Loka, because you're doing the first presentations. Just let me know, and I can help you through it if required.
Sir, it sounds like...
Hold on, guys. Hold on. Too many people talking. I can't see hands up. Loka, go ahead. What was that?
I do in my book and I send for you the
presentation. That's okay. Yep, that works. Not a problem. Sashwin, I saw your hand up as well.
It sounds like a great idea. I just thought that I want to do like that.
You will, definitely. So everyone will get a turn. We'll just do 2 per class to start with, and then we can even ramp it up down the track as everybody gets used to it. Okay, definitely. I want it to be something fun. So choose a topic that you enjoy. And yeah, we'll see how we go. I think it's going to be pretty fun. So Dinishan, yes, I see your hand up.
Sir, 1 week, 1 person, right? 2 person, right?
1 week, 2 people. So everybody will get a turn, but we'll go through different weeks. So by about the 4th week, everyone would have had a turn. Okay.
Loka, Priya, and Rahul say the presentation. So one by one.
Yes, 1 by 1. Correct.
Thank you.
No problem. Alrighty, let's jump onto Kahoot. So get the pages up and running, and I will pop it in our WhatsApp. Ooh, got tricky, that one. Sublimation, remember guys, is when we skip one stage. Okay. So that means you would go from the solid to a gas. If you're going from water to gas, that's evaporation. Sublimation is where you skip the liquid phase. Ritishan and Prinsika, well done. Got that one right. Oh, only one person got this one. What's going on? Everybody's forgotten the content from 2 weeks ago. Deposition, again, guys, skipping the liquid phase, right? So going from water vapor back to ice, which is the formation of frost. That's deposition. Let's see. Who got that one? Satvika, well done. All right. Let's see. Sarwin, 3rd place. 2nd place is Loka. And 1st place is Ritishan. Well done. Nicely done, guys. And we had Sashwin and Dinishin coming 4th and 5th. Awesome. That takes us to the end of the Kahoot. So a couple of things I just want to cover, guys, before we finish off. I know we're a little bit over time already. So if I can get everyone back on the Zoom just to cover last couple of points. As I said, Loka and Rahul, you guys have your first presentation on for next week's class. Any questions, pop it in the chat. I'll be happy to answer them. The rest of you guys have a look at a couple of videos on light meters and also how the clear ice is made. And then we can have a chat about that next week as well. Anybody have any questions, any comments before we close off?
No, sir.
Awesome. No dramas. Well, thank you guys. It was great seeing you all again. And I'll see you next week. Have a good one.
You.
Okay, bye.
Thank you.